to mu by rho. Mu is the dynamic viscosity and its dimension is ml t minus 1. As we see here, it is taken from here ml minus t minus 1, and the rho is the density ml minus q. So its dimension will be, this will be the cut, this will be cut. So we have m l square, as it goes l to the power minus, so plus 3, that will be l square t minus 1. So the dimension of the kinematic viscosity is l square t minus 1. Now third one is specific gravity. Specific gravity it is denoted by G. It is the ratio of unit weight of sample to the unit weight of water. That is G is equal to gamma S and the gamma W, and as it is the ratio of two similar quantities, so it has no dimension, that is M0, L0, T0. As it is the ratio of same physical quantity, now it is written here also, as it is the ratio of same physical quantity, so it is dimensionless and unitless quantity. Now the fourth one is Poisson's ratio. Poisson's ratio, it is denoted by mu or 1 by m. As it is the ratio of lateral strain to the longitudinal strain, that is the ratio of lateral strain to the longitudinal strain, or axial strain also, oblique axial strain. Here we are also looking that it is the ratio of two similar quantity, so it has no any dimension, that is the dimensionless quantity, that is M0, L0, T0. Now here we are going to giving you a list which has the dimensionless physical quantity. First one is strain. You are looking here, the first one is strain, second one is specific gravity, third one is Poisson's ratio, and fourth one is gradient I. Gradient I is the ratio of delta H by L. Delta is the head loss and the length of the sample. Length of the sample means the soil, and so it has, as it is the ratio of two similar quantity, so it has no any dimension, that is dimensionless quantity. So there are four quantities which are dimensionless quantities in this list, according to this list. Now we are going to discharge Q. Discharge Q is defined as we have already discussed you that first we should know the definition of the physical quantity. So the discharge is defined as the volume, ratio of volume to the time, and the volume is the dimension of volume is L cube, and the time, ratio of time, so dimension will be L cube T minus 1. Now the fourth one is modulus of elasticity. Modulus of elasticity, as we know that the modulus of elasticity is the ratio of stress to a strain, and a strain has no any dimension, that is the dimensionless quantity, so stress is only ml minus 1 t minus 2. Stress, so the modulus of elasticity has the dimension m L minus 1 T minus 2, as a strain is dimensionless quantity. Now we are going to, it is already written here, as a strain is dimensionless quantity, so quantity, some quantities has the same dimension. There are some quantities which has the same dimension. First one is stress, modulus of elasticity and pressure. This has the same dimension m L minus 1 T minus 2, and also the work and energy has the same dimension, that is m L square T minus 2. Now the surface tension, the dimension of surface tension, as we know that the surface tension is defined as the force per unit length, that is the force divided by length, and the dimension of force is m L T minus 2. We have already discussed it. So the dimension of length is L. So it will be that it will cancelled out. So the surface tension, dimension of surface tension will be m T minus 2. Now the angular velocity, the dimension of angular velocity will be 1 by t. Angular velocity is defined as the per unit time. So t minus 1 omega, it is represented by omega, as we know that the angular velocity is represented by omega. Similarly, the angular acceleration is represented by alpha, and its dimension is 1 by t square. It means that t minus 2. Now there are a Cauchy constant, first Cauchy constant, Cauchy constant C, and Cauchy constant is defined as V is equal to C under root R S, where V is the velocity, C is the Cauchy constant, R is the hydraulic radius, and hydraulic radius is the ratio of area divided by weighted perimeter, and the dimension of area is L square, and perimeter is also length, so this L will be cancelled. So the dimension of the hydraulic radius will be L, and S is the slope, it is the dimensionless quantity. So here we are not going to writing here as it is dimensionless quantity. So velocity, now here we are looking here, the dimension of velocity is Lt minus 1. Dimension of velocity is Lt minus 1 C L to the power half, because that quantity is R is in under root, so this will be under root L to the power half, and C, now C solving we get Lt minus 1 L to the power half, and this will be cancel out. It is the 1, it has 1 power and it has half power, so the power will be the half t minus 1. So Cauchy constant has the dimension, and this under root is written as under root L divided by t, and this is the dimension of Cauchy constant. Thank you.